This time, we're going to look at a question from Paper 2, Section A, Human Physiology. This is a data response question about urine formation and hemodialysis. Table 1 shows some information about the composition of the plasma, glomerular filtrate, and urine of a healthy person. Part 1 of the question asks you to account for the difference in the water content between the plasma and the glomerular filtrate. First, you should point out that the water content of the glomerular filtrate is greater than that of the plasma. To explain this phenomenon, we consider ultrafiltration in the glomerulus and the Bowman's capsule. Blood flows into the kidney via the renal artery. When it reaches the glomerulus, it is kept at a high pressure due to the pumping action of the heart. Water and small soluble molecules such as glucose, amino acids, salts, and urea in the plasma are forced through the thin and porous walls of the glomerulus and the Bowman's capsule into the capsular space, forming glomerular filtrate. Look at Table 1 again. The glomerular filtrate has a similar composition to the plasma, except that no proteins are found in the filtrate because protein molecules are too large to pass through the walls of the glomerulus and the Bowman's capsule. The proportion of water in the glomerular filtrate thus increases. Part 2 of the question first asks for the percentage change in the urea content of urine when compared with that of glomerular filtrate. The calculation goes as 2 minus 0.03 divided by 0.03, then multiply by 100%, which gives 6,566.67%. Next, the question asks for a reason for the change. Students may give reasons such as active secretion or little absorption of urea along the kidney tubule, which could not account for the huge increase in the relative urea content. You must mention that a large amount of water is reabsorbed, or the proportion of water reabsorbed is greater than the proportion of urea reabsorbed. Let's have a quick revision on the reabsorption process in the kidney tubule. Reabsorption mainly occurs in the first coiled tubule. All glucose and amino acids, as well as most salt, are reabsorbed by diffusion and active transport. As many solute molecules in the filtrate are reabsorbed back into the blood, the water potential of the filtrate becomes higher than that of the blood. Thus, water in the filtrate moves into the blood by osmosis. Due to the large amount of water reabsorbed from the filtrate, the urea concentration in the filtrate increases. About 50% of urea in the filtrate returns to the blood by diffusion. Part 3 of the question is about hemodialysis. Table 2 shows the concentrations of 3 solutes in the dialysis fluid and in the plasma of a patient with kidney failure. Which of these substances can be removed from the plasma of the patient during hemodialysis? Hemodialysis is carried out using a dialysis machine. The machine consists of dialysis tubing bathed in dialysis fluid. The dialysis tubing is differentially permeable. As the patient's blood passes through the dialysis tubing, metabolic wastes diffuse from the blood to the dialysis fluid down the concentration gradient. The concentration of useful substances such as glucose in the dialysis fluid, is the same as that in the blood. Thus, there is no loss in these useful substances during hemodialysis. We can see from Table 2 that the concentrations of chloride and urea are higher in the patient's plasma than in the dialysis fluid. Therefore, these two substances can be removed from the plasma during hemodialysis. When answering the question, you should mention that the dialysis tubing is differentially permeable or porous, and so it allows chloride and urea to pass through. This gives you 1 mark. The other 2 marks are obtained by comparing the concentrations of chloride and urea in the patient's plasma and in the dialysis fluid, and stating that chloride and urea diffuse from the blood into the dialysis fluid. Finally, you are required to give one advantage of having a kidney transplant over hemodialysis. Possible answers include no buildup of metabolic wastes in the body, reduced risk of infection from dialysis, as a long-term cure, or cheaper cost in the long term.